Get into like two things at the same time.
Yeah.
Didn't you tell us to like only focus on one thing?
I'm sorry. Hold on. So what's the first thing you need to do when you're working on these? What's the first thing? Someone raise their hand and tell me clearly. What's the first thing? Sarah.
Isolate one variable.
Does it matter? Does it theoretically matter which one you isolate? No, but is there generally one that might be the easiest one to isolate? Which x in which line? X in the third, yeah. So we like to isolate this one. So if we isolate that one, x is going to be 1 minus 4y plus what?
3z.
3z, exactly. So that's the first step. Isolate one. Try to pick the one that looks like it's going to be nicest. What's next? Someone different. Someone tell me what's next. Gabby.
You have to plug that back
Yeah, you have to plug them back in. Plug this one back in where?
into both of
The other two, right. So instead of x, you write, so it's negative 1 minus 4y plus 3z plus 2y plus 6z equals 2. Let's simplify this one first. What do I do with that negative sign?
You distribute it.
Negative plus. Is it really important that you don't do? Yeah, you got to remember it.
Yeah.
Yeah, you really do. If you don't, then it goes poorly. So then how many y's do I have on the left side? How many y's?
6.
6y. How many z's do I have?
3.
3z. So that got rid of, what did that get rid of there? That got rid of this, 4, 5, 6, and then 3 of them. And then what do I add to both sides?
1.
So it equals what?
3.
Equals 3. So that's our first equation that we have. Yay, that's one of them. But now we need to generate a second equation. How do we generate that second equation? Plug it in there. And what do we end up with? 3 times, instead of x, what do I write? 1 minus 4y plus 3z plus what?
2y.
Plus 6z. I was just reminded, a common mistake that I make sometimes is that when I'm copying over the equation, I'll sometimes mix them together. Like I'll get the first one from the first and the second one from the second and the third. When you guys walk up to me and you ask me for help, do you know what the first thing I almost always check is? Did you copy it down correctly?
Yeah.
Like literally, that's what math teachers do. We don't say it. We're like, okay, it is the right question. Now we'll actually devote time to it. So did I copy it to the right one? I think so. 3 times x, 2y plus 6z. So let's simplify this one now. If we simplify this one, what's one word? What do we do next? One word. Yeah, excellent. So 3 minus, and I don't want the emulator, but it's going to talk to me anyway. Let's see if I can make it go away. Nope, okay. 3 minus what? 12y plus 9z plus 2y plus 6z equals what? So how many y's do I have on the... Let's see here. Yeah, let's do this here. So we have negative 12 of them there and 2 of them there, so that's negative 10y. And then 9z and 6z, how many z's is that? 15z equals what? Nope. 3. So how many equations do we now have? We now have 2 equations and 2 variables. Now we like to use substitution. We have 2, so this is a 2 by 2 system. That's what it's called, a 2 by 2 system. Now in solving a 2 by 2 system, what can we simplify either one of these a little bit before we go any further? Can we? Someone answer that first. Which one? I'll give you a hint. Yeah, what could we do to this one? Divide by what? Nope. Divide by 3. No, I'm not waiting yet. I will go back in a second, but please answer this question. What do we divide this by to simplify it? 3. If we divide everything by 3, what do I get?
2y plus z
equals 1. Yeah, I just wanted to simplify that. Take what you can get, okay? Like take it. Yes, Noah, and then Sarah. So how many, this is one equation. How many variables are in there? 1. So theoretically, we can solve for y now. So we have negative 10y plus 15 minus 30y is equal to 3. How many y's do I have on the other side? Negative 40y equals, careful, negative what? Negative 12. So y is equal to 12 over 40, which is equal to 6 over 20, which is equal to 3 over 10. So when we plug this in, we end up with x is equal to, 1 is 10 over 10, so it's minus 12 over 10 plus what? 12 over 10? Does it, oh look, did it come out to be, what's that equal? No. 1. It comes out to 10 over 10, which is equals 1. So how do you write, so this right here, this is x right there. So how do you write the answer to this?
1, 3 over 10, 2 over 5.
Correct. There it is, right there. the same work. So what's that first step we like to do? What's the first step? Yeah.
Elimination.
We could do elimination, but we're not going to use elimination on this one. We need to isolate first. Our first step is always going to be isolate on these. And you get to choose which one you want to isolate. Which one do you want to isolate, Gabby?
I want to isolate the x in the second.
You want to isolate x right here? Absolutely. So if we isolate x right there, what does x equal? 17 minus what?
2y
Minus z. You with me so far? Where do we plug this x in now? Where do we plug it in? Only the top one, because there is no x in the bottom, which is fine. So we take this x, which is right here, we plug it into the top one, and what do we end up with? 2 times what? 17 minus 2y minus z, minus what? Sorry. Minus what?
Minus 3y.
3y plus 2z equals negative 1. We should simplify this using what word? 34 minus 4y minus 2z minus 3y plus 2z equals negative 1. Let's count the y's. What do we got for y's here? We got negative 4 and negative 3. So how many? Negative 7y, negative 2z, and positive 2z. What happens to those? They go away. And what should we subtract from both sides? Let's subtract 34. Negative what? Hey, can we keep solving? Yeah, what does y equal? Negative 35 over negative 7 equals 5. Is that nice? That's great. Hey, now that we have y is equal to that, where can we plug that into?
Wait, is that x?
That's y. Y is 5. So where can we plug that in? Look at the last one. So we know that 2 times 5 minus z is equal to 7. So 10 minus z is 7. So what does z equal? 3. So now we have, there's our y, and we have our z. So how do we find x? We already have one. Is it there? Look at the board. X equals what? We know that x equals 17 minus 2y minus z. So what are we going to say? X is equal to 17 minus 2 times 5 minus 3. You can almost write a 3 there. Let me clean that up. Minus 3. So we get x is equal to 17 minus 10 minus 3. So that's x equals 17 minus 13, which is 4. So if you had to write the answer to this, what would you write? 4, comma, done. On first. What's the first thing? The fraction. So what's something I know some of you did? Yeah, so I know that some of you multiplied this by 6. It's paused. Oh, it's frozen. Sorry. Yeah, sorry. So you multiplied by 6, so you ended up with what? 3x plus 4y is equal to? So you have 3 equations. 1, 2, and the third equation right there. So what's that first thing I asked you to do? Isolate. So you have to pick one. So unfortunately, there isn't one that's like the nicest one, right? There's nothing that shines, that screams isolate me. You have to pick one. What did you pick? Someone raise their hand and tell me what you pick. What did you pick, Hannah?
We just picked the last one.
You need to pick a variable and a line.
Oh, sorry. We isolated y and 3x plus 4y.
Okay, let's try this. And I realize how many variables? There's x, y, and z in first, second, and third, right? So there's really 1, 2, 3, 4. There's 6 different choices you can make. Each one is fine. Let's just pick that one for a second, okay? So if we pick that one, you know that 4y is equal to negative 6 minus 3x. So what does y equal? Negative 6 over 4 minus 3 over 4 what? Can we simplify that a little bit? Yeah, it's negative 3 over 2 minus 3 over 4x. What do you do? We're doing the same process. What do you do with this? You plug it in wherever y is, and there's only one y. Where is it? Yeah, there's a y right there. So what does this one now become? So we're going to take this and plug it in right there. What does it now become? It now becomes 4 times 3 over 2 minus 3 over 4x plus 3z equals negative 9. What should you do to that before you do anything else? We need to simplify, and that first step of simplifying is going to be distributing. So let's actually distribute there. You end up with negative 12 over 2 minus 12 over 4x plus 3z equals negative 9. What's negative 12 over 2? Negative 6 minus, what's negative 12 over 4? 3x plus 3z is equal to 9. What do I add to both sides? I add 6, so you end up with this equals 15, right? Oh, this is negative 9, so it's gonna be negative what? What could I divide each of those by? 3. So I end up with negative x plus z equals what? Negative 1. So look at what we have now. We have this equation. Is there one equation we haven't worked with yet? The top one. What's the top equation? 5x minus 2z equals 8. I just copied it down. How many equations do you see on the board? How many equations do you see? 2. How many variables? 2. So now we just do the process again. Of those two, Sadea, which variable is the easiest one to isolate, do you think? Which line, which variable? Top line, which variable?
Z.
Let's go with z. If we isolate z on this, you end up with z is equal to negative 1 plus x. So where does that put that? This is going to go where? So 5x minus 2 times what? X equals 8. So 5x plus 2 minus what? Equals 8. So we end up with 3x, yep, equals what? 6. So x equals? No. 2. See, x equals 2. So now you just work backwards. Now you know that x equals 2. Can you tell me, Chris, where do I plug in x equals 2 to get z? Look at the board. Where can I plug that in immediately? Exactly. We can take this and plug it in right there. Shh, kids, Chris speaking. So what's z equal? Negative 1 plus 2, which is what? 1. Noah, can you just shh for a little bit?
Hey there.
So now we have, hey, how you doing, Con? Hold on, Hannah. Did we make a mistake?
No, I just think I have a question while we're in the moment.
You could use any method you want. Totally fine.
Okay.
We have 3. You could graph it, and actually it would kind of work, but you should not default to graphing because we know it's not that accurate unless you're really careful. So we have 2 and 1. What can we plug it into? Let's go back and look. Did we solve for y? Look, what did we do first, everybody? What does y equal? Y is equal to negative 3 over 2 minus 3 over 4 times what? X, which is 2. So that's going to be negative 3 over 2 minus 6 over 4, which is negative 3 over 2 minus 3 over 2, which is negative 6 over 2, which is what? Negative 3. So what's the answer to this one? 2, comma, negative 3, comma, 1. Everything we have in this section kind of is based around this idea. We're okay with 2x2 systems. What's one thing we have feeding into 2x2 systems? 3x3, but the method is still the same. We're going to talk about something else that feeds into 2x2 systems. Does anybody know? No. We're not doing 4x4. That would be a natural. What did you say in the back there? Yeah. So instead, and we've talked about these before, instead of being given the equations, what might you have to do? Make the equation. So sometimes I'm still talking. Please. We might not have the 2x2 system. You might actually have to build it from a set of sentences, from something like a little story about bread or cars or mixtures, or bread and cars made of bread. So you've seen this before. You read the question. This is not new. You assign variables, you write a system of equations, you solve, you state, and you check. Which step do many of you try to start with?
Solve it. 6.
Making an equation.
Yeah, many of you start here. Please don't. For really, really, really straightforward word problems, you will be able to do this. But the second we step into something that's a little bit harder, what's going to happen? You're not going to be able to do it. You're going to make something up that's just not correct. You must read and then assign variables. So I guess if you get a second thing out of today, in addition to maybe a deeper understanding of 3x3, remember to read and assign variables. What does it mean, assign variables? Yeah, what does it mean, Gabby?
For all the variables
Yeah.
that you don't know in the equation, assign a letter that matches it so you're not confused.
Yeah, and state what they mean. So like x equals the miles that the race car travels. You have to state what it means. Sometimes you guys are going to do word problems that are going to ask something like, this is going to happen. Like, okay, car A is traveling to Philadelphia, car B is traveling to New York. How fast are they going, right? And your answer is going to be like 6,792,000, right? And you're going to go on to the next question, not realizing that that's not really realistic. Most of the checks with regard to realism, they fail because people don't assign variables.
Are you going to give us realistic?
Yes. So you might get a question that looks like this. A rectangular soccer field may have a width between 50 and 100 yards and a length between 100 and 130 yards. One particular soccer field has a perimeter of 320 yards. Its length measures 40 yards more than its width. What are the dimensions of this field? So first case, the first one, what now when you're labeling, should we call them like Z and Q? No, could we if we wanted to? Don't though. L and W. So is this enough to label variables? No. What does L represent? Length of field. What does W represent? Width of field. So we've read this and then we've written and labeled variables. What's our next step? Write a system of equations. So we now need to look at the story and say, what's one thing we know is true? Gabby, what's one thing we know is true?
I have a question.
We know.
Yep. W plus 40. No, yeah, I lied.
Close, yep.
It was, yeah, W plus.
Its length measures 40 yards more than its width. Its length measures
Yeah,
40 yards more than its width. So what is it going to be?
Oh, yeah.
There's going to be L and a W, but where do you put the 40?
On the other side.
It says its length measures 40 yards more than its width.
Okay.
You see? Remember we did this wrong? We flipped this around like a couple months ago, and Verdi was like, snap, I got it right. Yeah. So this time the length is, and you literally, length is correlates to equals. The length is 40 plus W. So that's one equation. But we have two variables, so how many equations do we need? Two. So we need a second. What's the second equation going to be, Hannah?
L plus L plus
So 2L plus 2W is equal to what? Yeah, because this is the equation for perimeter, right? 2 lengths and 2 widths equals the perimeter. How many equations do we have?
This is so much easier, yeah.
How many equations do we have? Two. And look, is L already isolated? Oh my god, yay! So L is right here. L goes right there. So Sadea, if I plug it in, I get 2 times what?
W.
Sadea, W plus?
Oh, 40. And then
Plus
2W.
2W equals 320. So we distribute like we've done before. Plus 2W equals 320. So 4W equals 240.
It's just not so easy.
So what does W equal?
60.
60. So we're not done yet because we have W. How do we? So L is equal to 60 plus 40, which is 100. So this field is 60 by 100.
Now you gotta go up to check.
You could check. And are they between 6 feet? Yeah, they are. They are. And is that 60 plus 60 is 120? 120 plus 200 is? 320. Is that the perimeter? It checks. It does check. So here's the thing. Remember, we are really happy when we get to 2 by 2. We might start with 3 by 3, but we can chip away at it and get to 2 by 2. But with word problems, if we're careful, we can immediately generate a system of equations that are relatively straightforward. These just take practice. And I can't say this I can't say this enough. Read and write your variables. It's by far the most common mistake that leads to like making it much harder than it is. So let's take a look at another one. For the 2008 to 2009 NHL and NBA seasons, 2 hockey tickets and 1 basketball ticket at average prices would have cost $148. 1 hockey ticket and 2 basketball tickets would have cost $148.60. What were the average prices for the 2 sports? How many? One of the variables, Noah.
NBA.
So let's use it. Let's call. No. NBA what?
That's what I mean.
You want to call NBA? The thing is, so let's call it a basketball. Sure, basketball. And what is B going to represent? That's true, but it doesn't represent a basketball.
That's the price of a basketball.
Average ticket price in NBA. Do you understand the difference between saying B is basketball and B is average ticket price of a ticket in the NBA? They're not the same thing, right? So what is H going to be? Average ticket price in the NHL. Take a minute and buy yourself. How many equations do we have? We have 2 equations and how many variables? 2. So yeah, Noah asked what method would we need to use? You can use substitution, you could use elimination, you could use whatever method you want. What I'd like you to do right now, try to solve for H and B. Do that right now. Solve for H and B. Who has B? Verdi, what'd you get?
49.47.
Who got 49.47? Let's see this here. Anybody get 49.47? You did? Now here's the thing. Can you check these answers to see if they're correct?
Yes.
Use your calculator and check. Do this right now. Everybody take your calculator, check these answers. Let's see if they're correct.